So next we're going to look specifically at single displacement reactions of nonmetals displacing nonmetals. So here we have nonmetal number 1 comes along, it sees an ionic compound, a metal bonded to a nonmetal, and it bumps out that nonmetal 2, steals the metal for itself, and now nonmetal 2 is the single element on its own. So let's look at an example here. Let's say we have chlorine, comes along, and it sees some sodium bromide. So let's just check all of our chemical formulas here and make sure we've got them. Chlorine is one of those diatomic guys, so that's going to be Cl2. Sodium has a charge of +1. Bromine has a charge of -1, so we have a ratio of just 1 to 1 here. That's great. That chlorine is a nonmetal. It sees the bromine nonmetal. It's going to bump that out and steal the sodium metal for itself. So we'll get sodium bonded to chlorine, sodium chloride there. Again, charge of 1, charge of -1, so that's the chemical formula is good. And the bromine gets bumped out on its own. Watch out though, bromine is one of your diatomics, so we need to make sure we write it as Br2. And that's how you do the displacement of a nonmetal displacing another nonmetal. Now, just like with metals, we have an activity series that this tells you whether or not a reaction will occur. So the only way a single displacement reaction will occur is if your single element here is higher on the activity series than the one it's displacing. So in the example we just did, chlorine was higher on the activity series than bromine. And so it could bump out the bromine, right, and steal the sodium for itself. But if this had been something like, a chlorine coming along and trying to bump out maybe a fluorine from sodium fluoride, then no reaction is going to happen here. This is not going to turn into anything because that fluorine is higher than chlorine on the activity series. And you'll notice that activity series is actually this is only for the halogens, and it's actually just the order that they fall in the periodic table, with fluorine being at the top and being the most likely to stay stuck to its metal than iodine at the bottom.